In order to know the physics of tennis, you must first learn about the racket and the history of it. When tennis was first created, a wooden racket was used up until the late 1960s, where Wilson produced the first T2000 steel tennis racket. With that, the game of tennis drastically changed. The racket would be able to withstand extra force and also be able to exert extra force as well. This is because of the oval shaped racket face rather than the older squared face racket. The same racket shape is used to this very day, however, the materials used has changed. The material used now are aluminum and carbon fiber composites. As you can see from the racket, it is spread into three different parts or sections: the grip or the handle, the throat, and the racket head. The racket head can also be known as a racket face or where the ball is meant to be struck. The strings are located in between the racket face and can also be changed according to player preferences. With a higher tension, less power is required to hit the ball as the bounce of the ball is increased, and if the tension is lower, more power is required to hit the ball. However, with lower tension, the ball can also be easily controlled. One point which could have an effect on tennis is how and where the ball is struck. There are a total of 4 factors: the dead spot, the node, the center of percussion, and the best bounce spot or the sweet spot. As you can see from the diagram above, the dead spot is in the top of the racket, the center of percussion is in the center of the racket, the node is also above the center of percussion, and the best bounce spot or the sweet spot is in the bottom of the racket. Ideally, every ball would want to be hit at approximately the best bounce spot depending on what the shot is. The next part is the first law of motion, which is an object at rest will stay at rest, an object in motion will stay in motion unless acted upon by an outside force. The first law of motion is affected by a total of 4 different factors. The first factor is gravity. The ball will always lower down as it passes the net. Second is the air resistance. Without air resistance, then the ball will just keep flying non-stop. Third is the friction. As tennis is a sport which allows the ball to bounce once, that bounce will slow the ball down with the contact with the ground. Fourth is the racket, which is the external force that sends the ball to the opposite side. The second law of motion is that the acceleration of an object is dependent upon how much force is applied to the object with constant mass. The formula for this is force equals mass times acceleration. As it is always constant mass, the force is proportional to the acceleration, meaning that if there is a higher acceleration, the force will also be higher. As you can see from the example which I have given you, the person is always adding extra force in order to smash the ball away and get a winner, rather than just letting the other person hit the ball back. The third law of motion is that for every action there is an equal and opposite reaction. As you can see from the example, the person volleying is having a very short backswing, meaning that he's not adding any extra force to the ball whatsoever. He is using the force that the person on the opposite side has hit to him, and the ball going back to the opponent's side will be as fast, if not faster. Here is a more clear example of the third law of motion. As you can see, the person hitting the ball, hitting to the wall, and the wall is reflecting back equally as hard, if not harder. The wall in this case will be acting as the previous example as the person volleying. The Magnus effect is the most commonly used effect in which a spinning ball or cylinder curves away from its
principle of flight path. This particular effect is used in many different sports such as American football, tennis, and volleyball. However, I will be only focusing on the tennis aspect. This relates to the spin or the topspin from when the tennis player hits the ball. The most basic principle is how a spinning ball creates a pressure difference in the field above and below it, or can also be known as air, leading to a net force from high pressure to low pressure when the ball spins. It creates a boundary layer, a thin layer of air that spins in the same direction as the ball. This is because the rough surface of the ball catches the air in its immediate vicinity, pulling it along its direction of motion. This could also apply to slices or backspin, which is the complete opposite of what happens with topspin. When a player slices the ball, it creates a lifting force that acts on the ball, creating backspin. Topspin will increase the ball's vicinity, whereas the backspin will decrease it. The way to measure this is by using the measurement of RPM or rounds per minute. As you can see from the force diagram of the ball above, it is in contact with the ground. Assuming that the ball has topspin, there are two velocities, the horizontal velocity and the tangential velocity of the outer rim. In this case, they are opposing each other. Knowing that the average radius is 0.0343 meters, the Vt equals Wr, which equals to 523.6, and the radius is 0.343, therefore equaling 17.99 meters per second.
In conclusion, there are many factors within physics that affects the wonderful sport of tennis. There are the Magnus effect, sweet spot, vibration nodes, center of percussion, dead spot, and the three laws of motion.